Welcome to engineering graphics. So today we are discuss the scales. So in the first unit, first chapter, scales. So scales. What is scale? First is the scale. So what is the scale? Scale is nothing but scales are type of so scales are nothing but generally used for a general engineering drawings. A scale is defined as the ratio of the linear dimensions of elements of the object represented in the dimension of the element of the object of drawing to the actual dimension of the same element of the object itself. So the various scales used in the practice are the first one is the plane scale. Second one is diagonal scale, and third one is comparative scales, and fourth one is vernier scales, and fifth one is scale of charts. So these are the types of scales. So generally scales are used for a ratio of linear dimension of element of the object as represented in the drawing to the actual dimensions of the same element of the object itself. Okay, so even though the types of scales are plane scale, diagonal scale, comparative scale, vernier scale, and scale of chart, so these are the very five difference of the scales. But in consider in our engineering graphics, only two types of scales are there. That is one plane scale and diagonal scale. These both are we are discussing in the our engineering graphics. And moreover, the plane scale and diagonal is a very important the your engineering graphics subject. Without plane scale, without dimension, these both, and without scale question, there is a no question paper at all. So either plane scale or diagonal scale, 10 marks question, definitely sure 10 marks question. So we'll discuss the now the plane scale. So before going to plane scale and diagonal scale, there is a introduction part of the scales. So we'll discuss the first introduction part of the scale. So there is a first one is the construction of scales. So construction of scales. So there is a different type of constructions of in the type of scales. There is a full size scale, and second one is reducing scales, and third one is enlarging scales. These are the construction of scales. We have to use full size scale, reducing scale, enlarging scale. So full size scale, it represents object of a normal size on a drawing sheet. Okay, very normal size. For best example of pen, now pen. Okay, the pen of height is 3 centimeter and width is 1 centimeter, and similarly height is 3 centimeter and width is like that only. If suppose full size scale, as it is you have to draw, it represent object of a normal size on a drawing sheet. Means the drawing sheet means you have to draw the perfect diagram, means very you have to draw the as it is object of the drawing, like a pen, a book, and water bottle, okay, etc. These are the very example of full size scales. If reducing, the name itself reducing, reduce, you have to decrease. So it represent the object very long size on a drawing sheet. So in reducing means you have to reduce, you have to decrease the size. If suppose our great Hyderabad or our village, we have to represent on a drawing sheet. Means how to represent, yes, consider as a one part of the diagram, like your I want to show a great India in a drawing sheet. So in Telangana I will show the 10 centimeter of the height and width is 20 centimeter, and Andhra Pradesh you have to represent height and width. So you have to separate and you have to reduce your scales, and then you have to suppose to draw a drawing sheet. So the best example is, I want show a great India in drawing sheet. Suppose you are reducing our college or your village. Suppose you have to draw any you have to reduce the scale and you have to draw the and you have to represent the drawing sheet. And enlarging scale, so enlarging, the name itself represent enlarge. Okay, you have to represent enlarge, like atoms, molecules, nucleus. So it represent objects of very small size of a drawing, very small size of a drawing sheets. So like atoms, so atoms is a very small small dimensions. So you have to elaborate, you have to enlarge a dimension. Molecules and nucleus, and your mechanical devices, like your watch parts, like that only how to represent. So construction of scales: full size scale, reducing scale, enlarging scale. These are the three types of scales. And here to represent, you are a very important. So you know the type of scales: full size scale and reducing scale, enlarging scales. But you have to represent some ratio. So without ratio you cannot draw any diagram. So that is a representative fraction, we called as a representative fraction, we called as, in abbreviation we called as RF. So RF is nothing but representative fraction or representative factor. So RF is used to identify the type of scales. Okay, RF is nothing but to identify the type of scale: full size scale or reducing scale or enlarging scale. It is the identify the RF is used to identify the type of scales: full size scale, reducing scale, and enlarging. It is represent a ratio of the length of the drawing to the length of the object. And in this formula is there. So RF is nothing but representative factor, length of the drawing by length of the object. Okay, RF is nothing but the formula of length of the drawing by length of the object. This is a very important, and this is the basic concept of the your representing the scale. So construction of scales, so you are selecting full size or reducing or enlarging scales. So you have to suppose to identify the which type of scales. So that is a representative fraction. So RF is nothing but length of the drawing by length of the object. Or else we called as another formula is there. Similarly, RF is nothing but dimension of diagram by original dimension, we called as another formula. RF is nothing but dimension of diagram by original dimensions. And next, LOS nothing but length of the scale. Okay, length of the scale. So you have to consider length of the scale. The formula is there. LOS is equal to RF into L max. This is the formula of LOS. So LOS is nothing but length of the scale. So before you have to construct a plane scale or diagonal scale, you need to remember the formulas, and you have to learn the introduction part of the basics concept. LOS, RF is nothing but representative fraction. The formula is length of the drawing by length of the object, or else dimension of the drawing or original dimensions. And the formula of LOS is equal to RF into L max. You need to remember very well. And one more formula is there, that is we have to learn to kilometers. That is the basic concept, is a very important. I will give you a easy way. Okay, so you have to start and centimeter, next decimeter, millimeter, decameter, hectometer and kilometer. Okay, so you have to remember these 7 words: millimeter, centimeter, decimeter, meter, decameter, hectometer and kilometer. This is a very important. And one more is inch, feet, and next add inch, feet, add. And one more is there, 1 inch is equal to 2.54 centimeter. Is a very important for introduction of the scale. So I will explain again. So introduction of the scale, there is a scale is nothing but generally engineering graphics to define a ratio of the linear dimension of element of the object as represented in the drawing to the actual dimension of the same elements of the object itself. Okay, there is a different types of scales. There is a plane scale and diagonal scale, and plane scale, diagonal scale, comparative scale and linear scales and scales of chart. So these are the very important in this scales of types. Plane scale and diagonal scale is a very important. Next more is a construction of scales: full size scale, reducing scale, enlarging scale. I am giving the examples of full size scale and reducing scale, enlarging scale. And next topic is representative factor. So without representative factor, you cannot draw any diagram of the scales. Either you have to identify the scale dimensions, either full size scale or reducing scale or enlarging scale. So you have to remember that one. So you have to calculate the first representative factor. So that is the formula of RF is equal to length of the object, length of the drawing by length of the object. This is the formula of the RF. RF is nothing but representative factor. So in that, next one is LOS. LOS is nothing but length of the scale. So length of the scale, the formula LOS is nothing but RF into L max. And you need to remember from millimeter to kilometers. So next you have to consider 1 decimeter is equal to how many millimeters. That is nothing but 1 decimeter is equal to 10 mm. 1 mm is equal to how many millimeters. 1 meter is equal to how many millimeters. You have to remember that one. That's why you have to by heart mm to kilometers: millimeter, centimeter, decimeter, meter, decameter, hectometer and kilometer. And you have to remember that 1 inch is equal to 2.54 centimeter. It is a very important to calculate the plane scale or diagonal scale. Inch, feet, add is a very important. And 1 inch is equal to 1 inch is equal to 2.54 centimeters. A very important, you have to remember. And the very important 3 categories of units. One is main unit, subunit, subunit. So main unit we called as MU, and subunit we called as SU, subunit we called as SSU. So main unit you have to consider, suppose 3.8, the distance of 3.8 means 3 is main unit and 8 is subunit. Okay, and here the 3.82 means 3 is main unit, 8 is subunit, 2 is subunit. We have to consider like that only. So we have to 3 categories, very important: main unit, subunit, subunit. These are the 3 very important in your plane scale. So we have to consider, first one is a plane scale. So first, plane scale. So plane scale, first question, see the first question. Construction of a scale of 1:4 of to show centimeters and long enough to measure up to 5 decimeters. This is a question. And show the length of 3.5 on the scale. So here we are considering construction of a scale of 1:4 of to show centimeters and long enough to measure up to 5 decimeters. Here not mentioned any scale name like plane scale or diagonal scale. Here not mentioned any scale. So we have to consider the distance. So the plane scale rules and regulations. Okay, rules of the plane scale. How to remember 2 points. So plain scale of the rules and regulation. First one is only main unit and subunit. The plain scale rules and regulation, first one is only main unit and subunit. And second rule is only have to consider the plane scale height. Plane scale height h is equal to 1 centimeter only. Any question or any diagram you have to mention the plane scale means the rule 1 is only main unit and subunit, and second rule is only the height of the plane scale is 1 centimeter only. So we have to follow the first solution. So we have to consider solution. So construct of a scale of 1:4. So given RF is equal to, so RF is nothing but representative file. It is identify the which type of scale. So here RF directly given 1:4. We have to write 1/4 also. To show centimeter and long enough to measure up to 5 decimeters. So up to 5 decimeter means a maximum length. A maximum length 5 decimeter. Okay, 5 decimeter given in the question only. And we know that the length of the scale LOS, length of the scale LOS formula, LOS is equal to RF into L max. This is the formula of LOS. So we have to give the bracket RF into L max, put in a box. Why? Because this is a very important. And RF, you have to suppose to direct RF is equal to 1/4 into L max. L max is equal to 5 decimeters. So we have to draw only scales in the centimeters only. So we have to, so manam use as a scale, we have to consider only scales of 1, 2, 3, 4, 5, 6 centimeters only. We know, and we don't have this scale of decimeter scales. So I have to consider decimeter into centimeter. So 1 decimeter is equal to 10 centimeter. Suppose here 5 decimeter is equal to how much? 5 into 10 centimeter is equal to 50 centimeter. Consider that. Next, put here, substitute 50 centimeter. Then calculate 1/4 into 50. Then got the LOS, length of the scale is equal to 12.5 centimeter. 12.5 centimeter. Now take the scale and pencil and draw a length of the scale first. Length of the scale how much now? 12.5. So 12.5, 0 and here 12.5. Draw a length of the scale. And next rule is draw a height of the scale is only 1 centimeter. 1 centimeter. Draw a rectangle box. You have to remember, draw a rectangle box and height of the distance is equal to 1 centimeter in the plane scale only. Okay, this is the LOS. And RF you have to should write in the middle of the scale. RF is equal to 1/4. And similarly have to write RF and meters, centimeters, both are in the same line. So consider. Okay, and next, from this is the how to write A and this one is B. From A to B you have to divide 5 equal divisions. Why? Because the distance AB, already question is given, AB is equal to 3.5 on a scale. So AB is equal to 3.5. So 3.5 distance. So you have to consider this is the below 5. So 3AB is equal to 3.5. That's why here cross it around the 5. So we have to round up 5. If suppose AB is equal to given 8.3, you have to round up to 10 equal divisions. Here 3.5 here given directly we have to consider 5 equal divisions. So from A and B And next from A to B, divide a 5 equal divisions. So totally 12.5. So 12. So consider the 5 equal divisions. It approx 2.5. Okay. So consider. And from A to second point, consider 0, 1, 2, 3 and 4. Okay. And draw a vertical lines with the help of scale. Draw a vertical line with the help of scale up to 1, 2, 3, 4 and from 0 to divide from left side, you have to divide 10 equal divisions. 10 equal divisions. So consider from 0 to left side 10 equal divisions. So consider from geometric construction method, from line divided into number of equal parts, or else you have to consider this is 2.5, approx 2.5 by 10 equal divisions, approx 0 point, like that only you have to come. So divide the 0 to 10 from left side onwards, you have to divide and you have to join the vertical lines up to rectangle box. And I have to consider up to rectangle box vertical lines and 0 to 11. This is the plane scale, and you have to mark the AB is equal to 3.5 centimeter. So where is the 3? This one is centimeters. I have to write in the centimeter, and this one is decimeters. And here consider the distance 3.5, 0, 1, 2, 3, 4, 5. Extension line, dimension line and dimension 3.5 centimeter. This is the plane scale rules and regulations. So plane scale have to consider this question. Construction of a scale of 1:4 of it to show centimeters and long enough to measure up to 5 decimeters. So this is the formula. RF is equal to given in the question, and maximum length also given, and length of the scale we have to substitute the formula RF into L max. You have to consider LOS 12.5. Then got a 12.5 length. AB is equal to 12.5 centimeter, and middle of the scale you have to write RF and divided into AB into 5 equal parts. Why? Because we have to given AB is equal to 3.5 centimeter. The distance 3 point. So it approx 5 below. So we have to consider 5. If 5 to above means you have to round off the 10 equal divisions. So it is easy to construct, and it is have to A to B 5 equal divisions. From A to second point consider 0, 1, 2, 3 and 4 and draw a vertical lines up to rectangle box. Then from 0 to left side you have to divide 10 equal divisions. Then write to what is you are dividing the centimeters and decimeters. Next consider 3.5. You have to consider extension line, dimension line and dimension. This is the plane scale rules and regulation and question.